So in this video, we'll be doing the assembly of a plumber block. So this is a plumber block. The plumber block will have the following components. We have got a block here. This is the part called the block. So this is the isometric view and this is the front view. So this is the block here. This is the first part. And then we have got a cover. This is the cover, and between the block and the cover there is a 3 millimeter clearance here being provided. Then we have got um, a brass bottom and brass top here. So two components are here, and the assembly will be done using a square headed bolt, two square headed bolts which will go through here, and completed by a normal hexagonal nut and as well as a locking nut. So these are the different parts that are there. So we'll do the assembly using Catia. So in order to do that, first we'll open Catia. Yeah, just a little bit. So this is the product tree. We don't need the product environment here. So I'll close this one and we'll start mechanical design, part design. And the first part that I'm going to create is the block here. So type block and give OK. And what I'll do is that I'll draw the front view and then I'll pad it over a distance of 62 millimeter. That's what I'm going to do. So since the front view is symmetric across this particular axis, then I'll draw one side of the block here and then I'll mirror it. So I'll first select this sketch and draw the profile. So profile, I have got a, see here I've got a vertical, an inclined line, another vertical, a horizontal, sorry, I've got a horizontal here, I've got an inclined line, another horizontal, horizontal, vertical, and a horizontal, and an arc of radius 35 millimeters. So this is what I'm going to draw. First I'll draw the horizontal, an inclined line, another horizontal, a vertical, horizontal, vertical, and another horizontal. First I'll dimension this and then I'll go with the arc. So this length, it is given as the entire distance is 292. So this is half of that. So 292 by 2, that becomes 146. Now that dimension is there. Now this one, the entire length is 172 up to this edge. So this is a circular edge, but first I'll draw it as a plane or a straight edge and then I'll cut it as we have done in our class. So this to this is 172 by 2, that is 86 millimeter. And now this edge, there is a 38 millimeter distance from the center. So from here, sorry, this is 172 by 2, and from here to here the length is 38. So that being done, all the horizontal distances are properly given here, except for this one. This we'll do with using the arc finally. Now we need the vertical measurements. So here to here distance, the height is given as 20 millimeter. So we have got a 20 here. Now an angle of 10 degree with the vertical is being given, mentioned for this particular line. So 10 degree with the vertical means 80 degree with the horizontal. Now this height, the entire height is mentioned as 110 millimeter. So this is 110, and this height, the height is being mentioned as 80. 80. From here to here, the height is. Now I need to create a arc or complete an arc here. The center of the arc is in the straight line with, or in same line with, this this edge here, this horizontal here. So this horizontal. So I'll select a center point arc, and first I need to select the center. I'll select the center in such a way that, see, you can see the two constraints being mentioned here. One is with the edge, this edge, this the center is now along the edge. And once I reach here, it gives me a constraint with the vertical also. So here I have selected the center, and I'm starting from this point, and I'm ending this point. So the radius, I'm mentioning it as 35. So now my one half of the section is complete. Now I need to create a mirror image of this. So I'll select this tool mirror, select the entire thing. Now I have got my entire cross section being sketched here. I'll exit the workbench and I will pad it. Now the entire distance is 62. For time being, what I'm going to do is that I'm going to give a length of 32 pad, and I'll give a mirrored extent. So 32 on one direction and 32 on another direction, so that I can keep the planes exactly in the middle. So sorry, it's 31. It's not 32, 31. So 31 towards left is forward and 31 backward, which makes it a total length of 62. So this is my primary cross section. Now I need to cut this particular hole, as well as I need to see, this edge is not a straight edge. Here we have got a flat edge, but here a radius of 86 is being mentioned. So this is a curved face actually. So I need to give that curvature, and also I need to create this, sorry, this circular hole. The diameter is 20 millimeter. So I'll do both of that in one stretch. So I'll select this face and I'll give sketch, and what I'll do is that first I'll draw an arc. So in line with the vertical, I'll select the center and I'll just create an arc. Any points will do. The only thing that we have is the radius is, the radius is 86. Radius is made 86 as mentioned here, and the center of the arc coincides with our center. So I make that distance 0, or we can give the coincide constraint here. So I'll just complete this arc using a profile tool. Just just for a close section here. Okay, and I'll create a circle also in order to cut this hole. So I have the hole here, and the diameter of the hole is given as 20 millimeter, 20 millimeter, and this should go up to this particular face, up to this particular face here. So both of them. So before pocketing, I'll just mirror this too. So mirror, I'll select these two, mirror with respect to horizontal. So I've got it here. And what is the distance to which I need to pocket? So 110 is this entire length, but both of them should end here up to this space, that is minus 20 millimeters. So I'm exiting the workbench, giving a pocket. So that is 110 minus 20, that is exactly 90 millimeters. So up to 90 millimeter, if you see, you have this curvature being mentioned. Now we need to create this particular geometry, that is the ellipse as well as the circle. Uh, the circle center has not been defined, I guess. The circle center distance should be It was not mentioned earlier in the drawing. I'll go to that particular sketch and edit it. The circle center to center distance is 132 from the center. Center to center distance is 132. So this is 132 by 2. So now it is properly done. So now we have it. Okay. Now we'll draw this the elliptical or long keyhole as well as the square headed hole in the block. So we'll select this particular face for sketching, and in the when we expand the rectangular section, we have this elliptical hole here. Okay, and the dimension of the elliptical hole is 20 in length and 20 in diameter. So this is 20, and the diameter is 20, so the radius is 10, and this point to this point, the distance up to here is given as 230 by 2, that is 115. So from the center to here 115 minus 10, that is 105. So 105 being mentioned here. Now I need a square cut here of 33 um, dimension. So the square 33 by 33, and then we need to extend it up to 20 millimeter downwards, and the center of that square is at a distance of 132 by 2, that is 66 from the center. So in order to get all these dimensions, I'll select a centered rectangle, and I'll dimension this as 33 by 33. Here a constraint was developed, so that is why it is showing this constraint I'm deleting. Then the center of the rectangle, the distance is 66, that is 132 by 2, so 66. So here we have got these two profiles. Now I'm going to mirror these two profiles with respect to the horizontal axis, exiting the workbench, and I need to pocket it. So pocket it downwards to 20 millimeter or up to last. So I have this all the geometries, main geometries being done here correctly. So now two fine finishing works needs to be done. The first one is we have got an edge fillet here, so I need to fillet this edge. I'll give just 5 millimeter here also, an edge fillet of that's arbitrary taken as 5 millimeter is being done. There is one more thing here, that is you have got to create a slut here, a hole here. So in order to do that, I'll select again this particular sketch here, and I'll use I'll draw just the section here, and I'll try to rotate it and create a hole. So I'll use a profile tool. I know the geometry is on the center. So I've got this profile here. The diameter is given as 6 millimeter. So I'll take the radius, that is 3 millimeter here. Now the height from here to here, I need to mention. So the height, so this is actually a 10 millimeter. So this height will be 10 millimeter, and so this height will be 10 millimeter from the center, and this from here to here is 35. So 35 plus 10, 45, 45 is there, and this entire length is 80. So 80 minus 45 should be the 80 minus 45. So I've got my length here, and I'll make this angle as 45 degrees. This angle 45. Okay. So that's it. Now this length is okay. Since it's outside, it won't make that much of a difference. So I'll use the groove tool here and I'll rotate it with respect to this axis. Okay. So now we have completed the entire block section. So I'll save this. So save as, create a new folder called Plummer block, and block is being saved here. Now next we need to create the first we'll create this particular cover here. So start mechanical design, part design, and I create cover. Now again similar procedure will be done in order to create the cover. So select this sketch. So what I'll do is that I'll see we have got the origin here. So I'll try to, in my sketch, this origin will be this point. Sorry, this origin will be the center of the arc. And this edge, mind it that this edge is a little bit above this particular line. So that edge will be above the horizontal axis, and that distance is being mentioned as 3 millimeters. So first I'll draw the profile here. So you will be having a horizontal, a vertical, a horizontal, a vertical, then a horizontal, and from here you will be having an arc of radius 110 millimeters. So this is what we are going to do. And so I'll use the profile tool and draw horizontal first, this horizontal, a little bit above the edge line. So horizontal, then a vertical, horizontal, vertical, finally a horizontal. First I'll just mention these dimensions. So from here to here, the length is 172 by 2, 172 by 2, and from here to here, 38, 38, and now this, for time being, we are not giving any constraint, but this distance we have, this ends at where? This is 132 by 2. So here to here, it should be 132 by, okay. So we have got the horizontal directions covered here. Now we need to go for the vertical. The vertical from here to here, the 3 millimeter should be there. So 3 is there. So from here to here, the entire height. Okay. So instead of giving that height, what I'll do is that I'll give this length, because it's directly given here as 22. Now I need to mention this height also. So finally that will complete our figure. So from here to here, I need to mention the height. So what is the height actually from here? So we have got a 3 millimeter here, and you have got this particular length here and a 3 millimeter. So if you find this length and plus 3, then that will give you this entire height. So what is this height actually? See, from here to here it's 80, 80 plus 3, 83. So the from here to here it is 110. So 83, 110 minus 83. So 110 minus 83, that is 27. So 27 plus 3, so 27 plus 3, that is 30 millimeter is the height. So from here to here 27 plus this distance of 3 millimeter, that is 30. So actually we need 33 here, right? 33, because we have selected from the center. So from the center 3 plus 27 plus 3, so that makes it 30. So now we have completed almost the dimensioning of this particular part. So now we need to complete it using arcs. So this arc is pretty much very simple. This one here. So here again, similar to the last one, we need to select the center point arc. But the center point arc will not be aligned to this edge. It will be, the center will be here, because we have got a 3 millimeter clearance between this edge and the center of the circle. So 3 millimeter clearance. So the center will be here. It will start from here and it will end here, and the dimension will be a radius of 35 millimeter. And then we have got this arc to be completed. The radius is 110, and the only thing is given is the radius 110 as well as the center of the arc. If you see, the center of the arc is somewhere in this particular vertical line. So we'll just create an arbitrarily, we'll just create an arc with center along the vertical, and we'll finally give the radius as 110. So it will automatically align itself to the required arc. Now we need to mirror this along with respect to vertical. Now we have got the shape almost here, and we need to pad it over a mirrored extent of 31 millimeter to both sides. Now we have the draft sketch here. Now we'll select this particular face in order to draw this arc as well as this hole. So again, center point arc here. From here, um, the radius is 86. We'll complete it using and then we need to create a circle also for the hole along center along this line. The diameter is 20 millimeter, and it's at a distance of 132 by 2, that is 66 from the horizontal. Okay, so now we have got these two here. Now we'll mirror it. So mirror it with respect to horizontal. Now I'll pocket it and give mirrored extent so that we have this here. Now if you can see this, there is a the hole is being generated this to this particular curved edge. So in order to change that, or in order to accommodate for the nuts, we need to cut a hole here. So again, I'll select that particular sketch itself, and I'll select a center point arc where the center, the radius is 25, being mentioned here, this one, and with the same center as the hole. So just select a, you can either select a arc or I'll do a circle itself, doesn't matter now, and the radius is 25, and this is at a distance of again 132 by 2, that is 66 from the center. So here we have it, and mirror it with respect to vertical, sorry, horizontal, and now I'll pocket it in the reverse direction. So we have this part here, and now there is one more thing that is pending here, and that is this hole. This hole I need to create. So in order to create that particular hole, what I'll do, I'll select again this plane itself, and give sketch, Now I'll using the profile tool, I'll draw just one half of it. And the dimension, there is 90-degree being mentioned here. That means that this edge to this edge, it makes 90-degree between each other. And diameter of 10 is given. So I'll go for dimensioning now. So from here to here, it should be the radius, that is 5 millimeter. And this makes an angle of, see, 45. So that makes it 45 plus 45, 90 degrees on both sides. And now its length needs to be mentioned. So this should exactly coincide with this here. So in order to do that, so in order to do that, here from here to here, we know the length, right? So this is 110 plus 3, sorry, from here to here. So here we have got this 3 plus 27, that is 30, 33 and 22. So 33 plus 22, 33 plus 22. Here we have got a constraint here, that is why constraint being defined here. Okay, okay. Need this to be constrained with respect to the vertical. It's constrained. Okay. What is this? Now, I think some dimensions have gone wrong now. Oh, sorry. We need it to be here, right? So what we'll do is that we'll project this 3D element. That's better way to do it. Project this one. Make this coincide. And this angle should be 45 degrees. Oh, actually, this diameter is 3 millimeter. Oh, here it is 10 millimeter. This is 10 millimeter. This is actually 1.5, and this is 5. That's how it goes. Okay. Okay. Now we have the hole here. So 45, 5. Automatically it will come down to this. We can delete this one. And exiting the workbench, I think there is an open profile. Let's see. We'll try to groove it with the vertical. And we get this vertical. So that being done, our cover is complete. So file, save as cover. Now next, we'll create this particular brass bottom and brass top. So what I'll do is that I'll create the entire part and I'll cut in order to create uh, bottom and top. So part design, brass bottom. So I can create this using a series of circles and then editing, or I can create using a shaft tool. I'll create using circles here. So go for sketch. I need to create the circles. First I'll create this one. So the inner diameter is 56 and outer diameter is 70. So inner diameter 56 and the outer diameter is 70, and this goes for a length of 62 millimeter. So I'm going to pad it, mirrored extent, give this as 31 millimeter. So again I'm going to select this space here, and I'm going to create this particular projection here of 10 millimeter, and the radius is 48. So I need to create two circles here also. One, two. The first one corresponds to the hole, that is 56 diameter, and the second one with a radius 48. So exiting the workbench, and I can pad it outside for a dimension of 10 millimeter. A similar profile is required on the reverse side also. So what I'll do is that I'll use the mirror tool instead of drawing. So part, I need to mirror this particular projection, so that is pad 2, and I'll use this mirror with respect to this plane. Now I've got my some part here, and I need to create this particular hole here. So in order to create that particular hole, select this plane and sketch. Just create a hole of diameter or radius 1.5 or diameter 3. Exit it, and I'll pocket it to last. I have my hole here, and I need to create this projection shaft here. So for that I'll select this particular plane, and I need to create a shaft here. You can use the user profile or rectangle, and this diameter is 6 millimeter over a length of 10 millimeter. So going to dimension this. So radius should be 3 millimeter, and the height should be 10 millimeter, and it should start from exactly here. So exactly here means at a distance of 35 millimeter. Here to here, the distance should be 35 millimeter. And, so instead of this 10, what I'll do is that I'll make the dimension from here to here as 45, and I'll extend this a little bit further. Extend this a little bit upward, so that I'll compensate for the curvature there. Now I can shaft it with respect to here. Now I have my entire. Now this is the brass. Now I need to create brass top and brass bottom. So I'll first select this as brass bottom, and the same file I'll use to rename it for brass top, and I'll do the editing here. So now this is brass top. So what I'll do is that I'll select this particular face. I'll create a rectangle. So this is brass top, right? So I'll create a big rectangle, and I'll pocket it up to last. So that I'll create this brass top here. I'll save this one. Now I'll go to my folder and create select brass bottom. Plummer block, brass bottom here. So I'll select this one using a rectangle. I'm going to remove the top part. File, see. Now I've got my brass bottom and brass top part being uh, created here. Now I need to create this particular. So I need to create this particular nut here. So I'm going to start mechanical design, part design, and square-headed bolt. So I need to create the bolt here. Nut we already have, so the bolt we need to create. So select this sketch, create a center point rectangle, and since this is M20 and the dimension is the square of 33 in cross section, 16 height. So first give those dimensions. So 33 by 33, and I'll pad it over a length of 16 millimeter. Select this space again, sketch it. M20, so 20 I'm going to create it plane. So radius is 10, and I'm going to pad it over a total length of 150. Sorry. So file, save as, bolt, and all our parts are complete. Now we'll do the assembly. So I'll start mechanical design, assembly design, and in our product tree, I'll call one by one. So first, I'll call the block. So the block is here. Now the first thing to do is select the block and fix it. Next, I'll call the brass bottom. So brass bottom is here. First, I'll manipulate this to bring it a little bit outside so that we can see what is being done. So here it's pretty simple. I need to coincide between this and this axis, and I need to make coincide again. I need to coincide between this projection and this particular hole, and these are the two things that I require. So once I give it, it is perfectly fit. No more surface constraints are all required here. So brass bottom is there. Now I'll call brass top. So brass top again, we need to do there. Since we created from same drawing. So brass top is here. I'll bring it outside first. Okay. So what we need to do is we need to build the coincide constraint between this and this surfaces, and then finally a surface constraint between, so this space and this space. Once I give update here, now I need to insert it properly. So again another surface constraint between here, say this space. So now it's perfectly being fit here. Now the next part is the cover. So cover is there. So here is the cover. So I'll manipulate this along the Z axis. Cover is here. Okay. Now I need to give coincide constraint between this axis, between this axis. Again a coincident constraint between here and here, and we have it updated. So 3 millimeter clearance will automatically come, or we can mention it or give it separately, but it should automatically come when we give these two constraints. Okay, and now we need to call upon the bolt here. So the bolt is here. Take it outside first. Okay, now we need to insert this bolt. So constant constraint between here and here, and we need to give the two edges, that is maybe this surface to this surface a contact, and maybe a perpendicular surface, and just another perpendicular surface constraint should be given. It's perfectly fit here. Similarly, I'll call another bolt again, take it outside as done previously, and give the constraints similar to what we have given earlier. And update, and it's all there. Now finally we need to insert the two nuts. So I'll open the catalog browser. I'll go for the ISO catalog. So we have got nuts here. First is section nut style 1 we can select. And we need M20 nut. So we need two such nuts. The nuts are here now. So I'll take it outside. So just place it. It's convenient for me to assemble. First need to create the constraints, coincident and the surface constraint. Same thing I need to do here also, the other nut also. So the nuts are being inserted. Now I need to call upon the locking nut. Again, catalog browser. You need to go down here, downwards. You can see the nut, thin nut, metric fine will do. Know what I've selected. So it's an M20 that I require. So 1, 2. We have got two M20s here. And I'll take it outside first. Manipulate. Okay. Coincident constraint. and this, another vertical constraint between this and this, surface constraint between this space and this space, surface constraint between this space, give an update, and you have got your plumber block assembly completed. Now we can try exploding it, and once you update, you can see it all here. This is the various views here, different side um, and top views with the isometric view here. This is the plumber block assembly.